Cosine law, part 2. So here I've got a triangle. I have to use the cosine law because I don't have a pair, the appropriate pair to use the sine law. I am going to start by labeling my triangle. This is little c, little a, and little b. And I know I have to use the cosine law. So here it is. And I need to find angle A in this question. So that means I need to get angle A all by itself. So I'm going to do that algebraically before I plug in my numbers. And that means I need to get rid of these two on the right side. So I'm going to subtract b squared and c squared from both sides. So they will disappear, but what I do to one side, I have to do to the other. So they'll disappear on this side, but show up on the left. So I've got a squared minus b squared minus c squared equals negative 2 times b times c times the cosine of a. And I put those little multiplication signs in on purpose because my next job is to try and get rid of these three coefficients. And they're all attached to the cosine by multiplication. So to get rid of them, I'm going to divide by minus times b times c. So they cancel, but what I do to one side, I have to do to the other. So now I have the cosine of a equals a squared minus b squared minus c squared times negative 2bc. The last step is you take the inverse cos, but I think at this stage it's good to plug in my numbers. We've got it pretty close to being a all by itself. So capital A by itself. So little a is 6.1 squared minus 11.2 squared minus 8.4 squared, all divided by minus 2 times 11.2 times 8.4. Now if you're entering this into the calculator, make sure you put brackets in the numerator and brackets in the denominator before you do the division. And you should end up with an answer of 0.8439. And now at this stage you can get rid of the cos, so the opposite mathematical instruction to cos is inverse cos, so I'm going to take the inverse cos of both sides. And it cancels on the right, and inverse cos of 0.8439 is 32.4 degrees. And if you're asked to find it to the nearest degree, that would be 32 degrees. So I'm going to start by labeling my triangle again, and just to show you that it doesn't matter what letters you choose, I'm going to start with this being F, G, and H. So this is little g, this is little f, and this is little h. And my question is find angle theta, which is angle F. So find angle F, which equals theta in this case. It's a Greek letter that often is used to symbolize angles. So I'm going to set up my known cosine law equation and replace the A with an F because I want to find angle F. If F is replaced there, it's going to be over here as well. And these two are the other sides, which are h squared plus g squared minus 2hg cosine. And I'm going to isolate, first of all, cosine of f. So I'm going to subtract h squared and g squared from both sides. And then I'm going to divide both sides by negative hg, 2hg, negative 2hg. And now I've got the cosine of f isolated, and I'm going to plug in my numbers. And that leaves me with 2420 squared minus 550 squared minus 6,000 squared, all divided by negative 2 times 550, 5,050 times 6,000. Again, watching your brackets when you're putting all this into your calculator, you should get an answer of 0.9183 equals the cosine of f. So if I take the inverse cosine now of both sides to isolate f, I get angle F equals 23.3 degrees.